Okay, as promised, I'm going to go ahead and finish up this lesson for you guys. So our next page should be this one right here. I am not going to do these problems. I'm going to leave those for you guys to practice. So go ahead and practice those at some point in time. See what you guys come up with. We can go over the answers to that at some other point in time. So we didn't get to this one. We want to find where the graph of f of x equals square root of 3 sine of x plus 3 cosine x has a horizontal tangent. So if we're looking for a horizontal tangent, we are looking for when the slope equals 0. So I need to find the slope of that function f of x, which means I need to take the derivative. So we're going to get that f prime of x equals, now the derivative of square root of 3 times sine of x, remember that the square root of 3 is just a coefficient. It's no need to do some kind of a product rule or anything. It's not the square root of 3x times sine of x. That would be different. It's just the square root of 3, which is a coefficient, times sine of x, so coefficient stays. So the derivative of sine is cosine. So it'll be the square root of 3 cosine x. And then the derivative of 3 cosine x, the derivative of cosine is negative sine, so it'll be negative 3 sine x. And we want that slope to be a horizontal tangent, which means it needs to have a slope of 0. We are now going to try to find the x values where that's the case. So that one doesn't look like you can combine those in any way. So what the best option would be is to take the 3 cosine x and add it to the right. I'm sorry, the 3 sine x and add it to the right. We really want to try and get this down into one trig function. So the only way to really do that is to think, well, if I divide cosine on both sides, I'm going to get 3 sine x over cosine x. And of course, sine x over cosine x is tangent x. So I'm going to divide both sides by 3 and make sure I reduce my sine x over cosine x to tangent x. So now this is a special unit circle value. I'm looking to find the angles of tangent that give me square root of 3 over 3. For those of you who don't rationalize, remember that's the same thing as 1 over the square root of 3. So either way is fine. So I'm going to look at that and think, well, 1 over the square root of 3 had to have come from 1/2 over the square root of 3 over 2. Remembering that tangent is sine over cosine, that means the numerator, sine, has to be 1/2. Well, that angle, where sine is 1/2, is pi sixth. And then tangent is also going to be positive in the third quadrant, which is 7 pi over 6. One other thing you should recognize about this problem, however, is that they did not restrict our domain, which means that this function just keeps on going. So really, each one of these has to add a 2 pi n to make sure that we account for every possible value of pi sixth or 7 pi sixth as we start to go around the circle a full time each time. Now technically, because pi 6 and 7 pi 6 are exactly 1 pi away from each other, we could have just gone with pi 6 plus pi n, and that would have been good enough. But this is probably the safer way to write it in this case. If it does restrict the domain, we don't need that plus 2 pi n on the end of either one of them. All right, the second one. Find the equation of the tangent line to the curve y equals secant x minus 2 cosine x. I should say at the point, not and the point, pi thirds 1. All right, equation of a tangent line. We need 3 things. We need slope, we need x, we need y. Well, we're given x, we're given y right there. We need the slope, which means we need a derivative. So I'm going to take the derivative of secant x, which is secant x tangent x minus 2 cosine x. The derivative of that's going to end up being plus 2 sine x because the derivative of cosine is negative sine, so it makes that negative out in front a positive. Now I actually need the slope at the point pi thirds 1, so I'm going to take the x value pi thirds and evaluate that in my derivative. So secant of pi thirds tangent of pi thirds plus 2 sine of pi thirds. This is why we do the trig table chart quizzes, because we need to be able to figure these values out relatively quickly. Secant, not one I typically remember off the top of my head, but I do know that it is the reciprocal of cosine, and cosine of pi thirds is one that I know. Cosine of pi thirds is 1/2. Therefore, secant, which is the reciprocal of 1/2, would be 2. Tangent of pi thirds, so again, I think of it in terms of sine over cosine. So sine of pi thirds is square root of 3 over 2. Cosine is 1/2. So I'm going to get square root of 3 over 2 over 1/2, which reduces to square root of 3. And then sine is one that I should know. Sine of pi thirds, again, is square root of 3 over 2. So it looks like I've got 2 square root of 3. 2 times square root of 3 over 2, the 2's cancel out. And that leaves square root of 3. So if I have 2 square root of 3 plus the square root of 3, that gives me 3 square root of 3. That is the slope of that graph where the tangent line meets at pi thirds and 1. So now I've got to plug this right into the point slope form. Y minus the y value, which was 1, equals my slope. X minus the x value, which was pi thirds. Absolutely no need to simplify it. If you were going to put this in on a WebAssign, you can leave it just like this, except yes, I know they want it in terms of y equals, so you would just add the 1 to the right. You don't even need to distribute, just add the 1 after the parentheses, you'd be good. Okay, last thing. The proof. Actually proving that f of x equals sine of x, then f prime is cosine of x. Alright, so we need to recall a couple of these special limits. You guys were supposed to have these memorized at this point. Hopefully you do. The limit as x approaches 0 of sine of x over x was 1. The limit as x approaches 0 of cosine x minus 1 over x is 0. That's important because we're going to have to use those in our proof. Okay, to prove that the derivative of sine of x is cosine of x, we are going to need the limit definition of the derivative. The limit as h approaches 0 of f of x plus h. Well, f of x is sine of x, so sine of x plus h is f of x plus h. Minus f of x, in this case, which is just sine of x, all over h. All right, at this point, not really anything that we can do as far as algebraically combining those things. But sine of x plus h, we did go back through this a long time back in the beginning of the school year. That is the sine of the sum of two angles, which splits to be this. Sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. And then don't forget to bring down the minus sine of x. Okay, so this part right here is an identity. That's the sine of the sum of two angles. We need to know that. All right, so here's what we're going to do. We're going to rearrange a little bit of the stuff on the top. So we're going to write, let's see, limit h approaches 0. We're going to write the sine stuff kind of together. So it's going to be sine of x cosine h minus sine of x, just bringing that minus sine of x to the middle, and then plus cosine x sine h all over h. All right, well, I can split the numerator because I have one singular denominator, so I'm going to go ahead and split this. I'm going to leave the two parts with the sine over top of h, so it'll be sine of x cosine h minus sine of x over h plus the limit as h approaches 0 of cosine x sine of h over h. All right. hopefully you're starting to see what might happen here. Notice that the limit is when h approaches 0. So sine of x can be split off of this top thing right here on the first one to be factoring out sine of x. Then I've got cosine h minus 1 all over h, plus I'm going to go ahead and split the second one to just be cosine x times sine of h over h. Hopefully what you can see is that this first one is the limit as h approaches 0 of sine of x times cosine h minus 1 over h, plus the limit as h approaches 0 of cosine x sine of h over h. Well, if you're really thinking about it, this one and this one are our special limits that we took up at the top. The first one, the limit of cosine h minus h, cosine h minus 1, over h, this one goes to 0. So the limit as sine of sine of x, because there's no h to plug into, sine of x doesn't really matter because it's going to be 0 for that whole thing. Plus, over here, the limit as h approaches 0, so the limit of this piece as h approaches 0, well, there's no h to plug anything into, so really it acts as if it's a constant, is cosine x, times the limit as h approaches 0 of sine of h over h, that's another special limit, that was 1. So ultimately what I get is 0 plus cosine of x times 1, or cosine of x. So there's the proof that the derivative of sine of x is cosine of x. So that, notationally, is f prime of x. And there you have your proof. The proof of cosine can be done in a similar fashion. I might leave that for you guys to do at some point in time. Other than that, you guys have enough. The packet is finished, and you guys should be good to do your WebAssign. All right.